Okay, everybody. This will be another video for the another decision theory example. Criteria which we'll be doing to deal with expected value of perfect information. So for the expected value of perfect information in this example right now, this is talking to the let us define first what is it. So this is a concept wherein we are using this is the concept used in decision theory to quantify um the the maximum amount a decision maker would pay to obtain a perfect information before making an information. So it refers to the impact and decisions when more information is provided so that the decision make can reach a point of certainty. So it can be found by adding up the maximum value and subtracting this from the expected value as well. So there we do have here then a specific formula of expected value of perfect information, which is equals to the expected value with perfect information minus to the expected value without perfect information. So please be reminded that the expected with without perfect information, that is still EMV. That is the expected value. So now, in this case right here, suppose you are a product manager tasked with pricing a new product um, that pricing a new product that your company is about to launch. You have two pricing option, which will be the $50 as well as the $100. So based on your market research and analysis, you estimate the following demand and profit scenarios. So there you have that. You do have option of one price at $50, which the probability of high demand will be 40%, and for the second, or the high demand D2 or the decision two will be the 60% when your profit is the profit if high demand is equal to 80%. If low demand is absolutely 20%. So for this right now, for the option two, you have the price of $100 as well, so which your probability of high demand is a 30% and your low demand is 70%. So your profit if high demand is 120,000 and if low demand is 40,000. So that is somewhat we will use that later on. So you can somewhat get the EMV for that later as well, because we have to identify the expected value with perfect and without perfect. And without perfect, that is the EMV or the monetary value. So expected value of perfect information, we'll begin to deal with that. So for the expected monetary value, or expected value without perfect information, so you will just simply deal with this. So 60% if profit is high, so times to the high as well. So that is 80%. 40%, no, that is 40% if high, then 80%. So 60% if low, then 20%. You have to time that and add them for the expected value of perfect without perfect information. Then for here, that is 30% if high times to 120%. Then 70% times to the 40%. So let's take that one by one. So that is 0.4% times 80, that equates to 32,000. 0.6 times 20,000, it equates to 12,000, and that is adding them will be 44,000. Now for the option two, what you will need to do in this case, you will need to identify 0.3 times the 120,000, then plus to 0.7 times 40,000, that equates to 36,000, and 28,000. So you will add them, that is 64,000. So you have to compare as well what is the best alternative with that, because the best alternative that you will be going to use in your formula because will be the best alternative for the EMV. So comparing with that, the best alternative will be the 64,000. So that is option 2. So that will be your best alternatives in this EMB. So now let's actually calculate the EV with perfect information. So with perfect information, actually, how can we determine that? So for determining that one, that is exactly, you will, of course, you will identify, and if talking to high demand, so you will check if high percentage, you will check the high possibility. If talking to the low demand, you will talk to the low priority as well. So let's actually define here then. So for if high demand, you do have high demand right there is for the 40% for the option 1 and 2, comparing them. So there is for we can for choosing 40% and 30%, which is the highest if highest demand, which is better, is it 40 or 30? So exactly, we can definitely choose 30 for the 40%. So that is for the $50. Now, what about if high demand for the profit? Is it 80,000 or is it 120,000? So we can definitely get the 120,000. So you can actually see here that it is 120,000. So what about for the option 2? I mean, low demand. Is it 60% or is it 70%? So we can definitely choose 60%. Then for the low demand of $20 and $40, what is low having low result? It will be $20, $20,000. So that is the thing that we will be going to a deal when it comes to expected value of with perfect information. So now, what you will need to do, you have to multiply the your option as well for the expected value with perfect information. So your expected value that is you've actually identified earlier that you will be going excuse me, that you will be going to, since we were able to identify that one already, so that is 0.4% times naman nimo sa high demand, which 120,000. So plus da yun sa low demand, which were you able to check the 60%. No, yeah, for the low demand, 60%, 0.6 times to 20,000. So let's actually calculate that. So it will be something like this. So it equates to 48,000 plus 12,000, and that equates to 60,000. So that's how you will deal with the expected value with perfect information. So what is the next now? You will calculate the expected value of perfect information already, calculating the EV with expected value with perfect information minus the EMV. So your EMV right now is 64,000. So 60,000 minus 64,000, that equates to negative 4,000. So that suggests that knowing the exact amount of exact demand scenario, perfect information, it would actually decrease your expected profit compared the best decision without perfect information or EMV. So that is mabankrupt ang imong nga business or ang imong nga plano. So therefore, there will be there's no good right there. Now, there is another example for the investment decision example. Imagine you are considering investing in a new technology startup where there is a decision whether to invest 100,000 in the startup or not. So your estimation, you do have you estimate the following payoff based on the success or failure of the startup. So if the startup succeed, estimate payoff is 300,000. If the startup fail, estimate payoff is $0. So if success, ang imong probabilities is $50. So if failure, 50%. That's 50%. I corrected. Now for this one right now, for startup for the EMV, it will be 300,000 times 50%, $0 times 50%. So for the expected value of perfect information as well, it will be the same because there is only one option that we can deal. So sa kung ano siya, kung mag-success, what is the good thing? Because there's no other category for another success. You cannot compare them. So automatic si 50% and $300,000. And for failure naman, $0 gapon kag 50%. So therefore, for expected value with perfect information, that is 150,000, and calculate the expected value with if you know the startup will succeed, you would invest 100,000 and get a payoff of 300,000. So if you know the startup would fail, you would not invest and get a payoff of $0. So for this one right now, calculating the EVPI, AVWPI, it will be the same thing. Calculating the EVPI, it will equate to 0. So that means to say, which means that with the current probabilities on payoff, there is no additional value in terms of expected payoff to be gained from obtaining perfect information before making the investment decision. So that's how you will deal with expected monetary, with perfect information. So we'll be going to give you another example in the next video as well. Thank you so much.